Yeah, it's the same day. I just changed my shirt. It is later than it was last time I filmed. So, I'm going to try and make this a short video so that I don't have to edit that much. That's why I'm talking really fast right now. Okay, let's get into the video. So, assuming that you need this information and that you are already at this point in math where you would just need some more help on this specific topic, like I'm not going to do what I did last time. I'm just going to assume that if you click on this video, you need help with this one specific thing and you've already done all the other steps to get here. Okay, cool. Or you're just really bored and decided to do this for some reason. Okay, transforming quadratic functions. I personally think that this is the easiest thing that I've learned so far in algebra. I'm probably lying because I don't remember that much of algebra 1 through 3. But, you know, it's cool, it's cool. So, I've got my notes. Don't worry, I'll put pictures on the side and whatever. I'm already pretty good at that by now. Here's the notes. So, I'm just going to go ahead and read through it. I'm going to go ahead and read through it. Then I am going to walk you through the steps and kind of like do worksheets with y'all. So, that's what we're going to be doing. Okay. Vocabulary. Parent function. Original base function. Parent linear function. Y equals x or f of x equals x. Parent quadratic function. Y equals x squared or f of x equals x squared. Same. Transforming a change in the size, shape, or position of the original parent function. Dilation. Change in size or width. Like the width. Like you're pulling it apart. The width. If A is greater than 1, the graph is narrower. Vertical stretch / horizontal compression. Oh, so it goes this way, stretches this way, or it gets squeezed up, therefore it's like that. So it's like here and then it's squeezed. You know? Whichever way you feel like thinking about that. If A is greater than the number 1. If A is less than the number 1, it'll go wider. Or, I don't know, like it'll be spread apart. Like if you had this, you're doing that. Vertical compression or horizontal stretch. Translation. Change in position, shift up or down, aka slide. If C, so you have to know the formula to get the basics of this. If C is greater than 0, the graph shifts up C number of units. If C is less than 0, the graph shifts down. So on the y-axis, the graph can go up or down. Or not the graph. Yeah, the thing that you are graphing can go up or down. Reflection. Change in direction, aka flip. So, like if you're looking into a puddle, your reflection it'll reflect. That's not, so like if you're looking in the back of a spoon, you'll be upside down in the spoon's reflection. So that's kind of what the reflection of this is signaling toward. If it's greater than 0, it'll reflect upward or open upward. If it is less than 0, if A is less than 0, it opens downward. The formula, the standard form of a quadratic, is y equals ax squared plus bx plus c. The main idea of this unit is compare a transformation of a quadratic function with the graph of the function f of x equals x squared. An example of this would be, compare the graph of each function with the graph of f of x equals x squared. So this, you can see all my writing on this, but this is that. And so how you would describe this, so pay no attention to the answers. This is the equation for graphing the line. So this is graphing like we did in the last part of this unit, but you don't actually have to graph it. So this specific one is vertical compression, and it translates down 10. So you can see that it is this because the fractions lets you know that it's vertical compression. For dilation, it's a vertical compression, so the graph will open wider, and it translates down 10. It translates because you can see in the C position. I don't know if you can see any of that actually, but you'll look at the notes on the screen, and at the end of the video I will put pictures of the notes as well. Okay, so for practicing, if you want to write these down on your own, I will actually be solving them because this video is only 7 minutes so far. I'll be writing them down and walking you through the steps as to kind of how to get in the mentality of it. Then don't tell my teacher, haven't done my homework yet, so we can do a few questions on here. Okay, so compare the graph of each function with the graph of f of x equals x squared. A of x equals x squared plus 6. That equation, is that an equation? That coordinates, I'm not quite sure what to call it. Oh no. That position? I don't know. That translates up 6. That is all that we can get from this equation. I'm going to say equation. Okay. B of x equals negative x squared plus 5. So that rotates. That's right. No, it does not rotate. Oh dear, I'm on a different unit. It reflects. So it flips. It translates up 5, and it dilates vertical stretch. So it goes this way. It goes skinny. And you can tell because it's a whole number, and because it has the negative in the front, that's how you know that it reflects. And you know that it translates up 5 because it's a positive 5, not a negative 5, where it would go down. So that's basically the gist of this. Okay, now let's try a few. Gotta scoot my pillow up forward so that I'm close to the camera. Yeah, I'm sitting on a pillow. Don't judge me. Okay. So this is 6H of the Unit 6, Transforming Quadratic Functions. So this first one I've already solved. It is g of x equals x squared minus 2. So all we can get from that is it translates down 2, because hence the negative 2 in the C position. I don't know if I said that correctly in the correct math terminology, but that's, you get the gist of it. Okay, no, because it's not going to take me 5 minutes. Okay. So I hope y'all have a wonderful evening. I will do a part 2 if you want me to, and we can work out more of these problems. Love you all very much. See y'all later. Bye.